Okay, so what we have here is a plane is inclined at 45 degrees to the horizontal. A particle is projected up the plane with initial speed u at an angle theta to the horizontal. Now, and they're nice enough to put it in a bold for you to really spell it home what's going on here. Okay, it's 45 degrees. We're all okay with that. That's no worries whatsoever. Usually we say, oh yeah, look, angle theta here. Brilliant. Angle theta to the wedge. This time that's not the case. What is the case this time? What's the difference? That's 45 degrees, and this thrown angle theta, which is here, it's actually not to the inclined face. It's actually to the horizontal. So that makes that theta. What does that make this angle in here? Theta minus 45. So it's a unique setup for something we haven't done yet. Now, the plane of projection is spherical and contains the line of greatest slope. That's like saying the grass is green and the sky is blue. They just say that, and what it just means is do it exactly the same way you've always done it. It doesn't affect you in any way, shape or form. The particle is moving horizontally when it strikes the inclined plane. Show that tan theta equals 12. Now, it's moving horizontally. That's an interesting concept right there. So, if we were to zone in on the wedge itself, okay, moving horizontally means what? If that's the wedge, how are we landing? What way are we landing? Parallel to the x-axis. We're landing this way here. This means that your landing angle must be 45 degrees. And do you remember what our landing angle is? I'll do it in pink here. Our landing angle represented by the landing angle's components are represented by the two pink lines. Can anybody tell me what those two pink lines are? Phi x and phi y. Now phi y is negative. So when we know that's 45 degrees as well by alternate angles, your landing angle, I'll just call the landing angle tan L. Landing angle is minus phi y over phi x. Phi y is guaranteed to be negative, and to make sure that you're getting an acute angle, you got to put in a minus there to adjust it. So when you tan inverse it, you'll be getting yourself an acute angle, not an obtuse angle. Okay, so look, we've learned lots already from this, and we automatically know where to go. We have to find phi x and phi y. When do we have to find them? When do we have to find phi x and phi y? Phi x and phi y at time of flight. How do you get your time of flight? What always happens at time of flight? No matter what the stipulation, no matter what other wording they give you, what you're guaranteed is that sy is 0 at the time of flight. When you land, you have no distance over your y. So we've got a load of information here. It's just a matter of us actually getting there now. Okay? So what we're going to do is this. We're going to set up phi x using phi equals u plus at. We're going to set up our S equations using ut plus a half at squared. We're going to need a gravity triangle. Anybody know the gravity triangle? G goes directly down. What else happens? 45 degrees in here. Probably do with that making it a bit bigger. Go again. Gravity triangle. That's it there. Resolve it parallel and perpendicular to the plane. That's G. That's 45 degrees. That's G cos 45, which is G over root 2. That's G sine 45, which is G over root 2 as well. Let's begin. And then we need to break up our initial velocity. Our initial velocity is represented by this green line here. Okay, I'll just yank it up here for a second. And this green line here also has a horizontal and a vertical component. Horizontal to the inclined plane, it's going to be it's speed u, isn't it? Yep. So that's going to be u cos theta minus 45. And this one is u sine theta minus 45. Everybody right with that? Now let's begin. Phi x is u, which is u cos theta minus 45, plus at, but our acceleration is actually acting against us, so it's going to be minus g over root 2 times t. Equation number 2, phi y. It's the y component of our initial velocity, which is u sine theta minus 45. Once again, minus gt all over root 2. We're not necessarily asked for sx, are we? Is there anything about range in the question? There's nothing about range, and so there's no reason to get sx. But you might do just by default, but we'll just go straight to sy, save ourselves some time. Ut, so this u value here multiplied by t, so it's ut sine theta minus 45, and then minus a half gt squared, so it's going to be a half of this, add on a t, so it's going to be 1 over 2 root 2 gt squared. I'm going to follow my formula here. I'm going to get sy equals 0. I'm going to isolate the time of flight. After I isolate the time of flight, I'm going to place it into phi x and phi y and figure out what phi x and phi y are at the time of flight. That's my plan. So sy equals 0. Save yourself a bit of writing, and now you're going to get a 1 over 2 root 2 gt squared ends up to be ut sine theta minus 45. I'm going to cancel that t with that t there. I'm going to multiply up to 2 root 2. 2 root 2 u sine theta minus 45 equals t all over g. Now that's a bit of a mouthful, okay? Now, just check up on that. Good to go, okay? Let's find phi x and phi y. So I'm going to bring out my phi x and my phi y. Put them down here underneath. Up. Let's try this again. Nope. There we go. There we are. And this thing here, you can get a bit smaller. There we go. Alright. Start off with phi x. So phi x is going to be phi x. Okay, so phi x equals u cos theta minus 45 minus g over root 2 multiplied by 2 root 2 u sine theta minus 45 all over g. G cancels with g. Root 2 cancels with root 2, and I'm going to get that phi x is u cos theta minus 45 minus 2u sine theta minus 45. That's still pretty large and pretty complex, okay? I'm going to go to phi y now, do the same trick. Phi y equals u sine theta minus 45 minus g over root 2, once again times t again, isn't it? So I've already done gt over root 2, haven't I? I did gt over root 2 already, so I'm just regurgitating old work here. So all I have to do is just put in this part here. Yeah, it's the same ending, so why not do it here? What are we guaranteed about phi y again? What's a good omen for your what's a good sign that we're on the right track? It's a negative. So that's a pretty good sign we're on our way. Okay? Now, do you remember we spoke about the landing angle earlier? The landing angle, tan of the landing angle. What is our landing angle this time around? It's tan 45. And our tan 45 equals minus phi y all over phi x. And if you ask me, minus phi y is u sine theta minus 45. I multiplied it by minus. And I have this all divided by u cos theta minus 45 minus 2u sine theta minus 45. Try and squeeze all that into there. Just going to rub that little middle part out. Bring this here. Bring it over. Now, can anyone tell me what's tan 45? Tan 45 is 1. So since it's the number 1, we can cross multiply and we get u cos theta minus 45 minus 2u sine theta minus 45. Hopefully not. Now what we get here is we bring the 2u over to your side and we get u cos. I think those u's can disappear pretty soon. And what we got here was that we're going to get u. Sorry, the u's are just going to go. I'm sick of them. Okay, it's 1/3 equals sine theta minus 45 all over. That's the worst line ever. Cos theta minus 45. What's sine over cos again? So tan theta minus 45 equals 1 over 3. Now, our beloved compound angles with tan, right? What's tan A minus B again, guys? Anybody remember tan A minus B? Somebody's prepared for his maths exam. Now, so what we get here, guys, is this. Tan theta minus tan 45 equals 1 plus tan theta by tan 45. Now, see tan 45? That's 1. They're 1s, and that equals 1/3. So, long story short, I'm going to get rid of those tan 45s. Just they're number 1 anyway, so just leave that one as 1. And there we are. Now, that's cross multiply now. 3 tan theta minus 3 equals 1 plus tan theta. Bring all the tan thetas onto one side. 2 tan theta equals, bring that one over to the other side. Is that 4? Yeah. And tan theta will be equal to 2. I think that's the end of the question. Yeah.